Hello, students. Have you ever wondered what everything around us is made of? This question fascinated ancient thinkers like Maharishi Kanad in India and Democritus in Greece. They imagined that matter could be broken down into tiny, indivisible particles called parmanu and atoms. Let us now understand the world of atoms and molecules in this Science Class 9 video. Atoms and molecules are the smallest building blocks of matter. They make up everything we see and touch in the world around us. Early ideas about atoms were based on thoughts, not experiments. Antoine Lavoisier and Joseph Proust created laws of chemical combination to explain how atoms and molecules combine. Let us discuss these two laws of chemical combinations. First law is law of conservation of mass. This law states that mass can neither be created nor destroyed in a chemical reaction. For example, mixing barium chloride and sodium sulfate solutions forms a white precipitate of barium sulfate, and the total mass before and after the reaction remains the same, proving the law of conservation of mass. The second law of chemical combination is law of constant proportions. Law of constant proportion states that in a chemical substance, the elements are always present in definite proportions by mass. In a compound such as water, the ratio of the mass of hydrogen to the mass of oxygen is always 1:8, whatever the source of water, that is wells, rivers, etc. Thus, if 9 grams of water is decomposed, 1 grams of hydrogen and 8 grams of oxygen are always obtained. The next problem faced by scientists was to give appropriate explanations of these laws. British chemist John Dalton provided the basic theory about the nature of matter. Let's now see Dalton's atomic theory, which was based on the laws of chemical combination. All matter is made of very tiny particles called atoms, which participate in chemical reactions. Atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. Atoms of a given element are identical in mass and chemical properties. For example, carbon is an element made up of carbon atoms only. Atoms of different elements have different masses and chemical properties. For example, atoms of oxygen have greater atomic mass than atoms of hydrogen. Atoms combine in the ratio of small whole numbers to form compounds. For example, 2 hydrogen atoms combine with 1 oxygen atom to form H2O. The relative number and kinds of atoms are constant in a given compound. For example, water, whether tap water or mineral water, is made up of 2 atoms of hydrogen for every atom of oxygen. Now, what exactly is an atom? The building blocks of all matter are atoms. Atoms are very small. They are smaller than anything that we can imagine or compare with. Size of an atom. Atomic radius is measured in nanometers. 1 nanometers equals 10 raised to the power minus 9 meters. Here is a table showing the relative sizes of different things. You can see here that an atom of hydrogen is having a radius of 10 raised to the power minus 10 meters. A grain of sand is having a radius of 10 raised to the power minus 4 meters. Now, what are the modern day symbols of atoms of different elements? John Dalton was the first scientist to use symbols for elements. Vesalius suggested that element symbols be derived from 1 or 2 letters of the element's name. The IUPAC approves element names and symbols. Many of the symbols are the first 1 or 2 letters of the element's name in English. The first letter of a symbol is always written as a capital letter, uppercase, and the second letter as a small letter, lowercase. For example, hydrogen and aluminium. Symbols of some elements are formed from the first letter of the name and a letter appearing later in the name, for example, chlorine and zinc. Other symbols have been taken from the names of elements in Latin, German, or Greek, for example, iron and sodium. You can see here the table of symbols of some elements like aluminium, cobalt, copper, neon, nitrogen, zinc, and more. Let us now understand what is atomic mass. According to Dalton, each element had a characteristic atomic mass. Since determining the mass of an individual atom was a relatively difficult task, relative atomic masses were determined using the laws of chemical combinations and the compounds formed. For example, 3 grams of carbon combines with 4 grams of oxygen to form carbon monoxide. In other words, carbon combines with 4 by 3 times its mass of oxygen. Suppose we define the unit of atomic mass as equal to the mass of one carbon atom, then we would assign carbon an atomic mass of 1 U and oxygen an atomic mass of 1.33 U. As carbon combines with 4 by 3 times its mass of oxygen, and 4 by 3 is 1.33. However, it is more convenient to have these numbers as whole numbers or as near to a whole numbers as possible. For a universally accepted atomic mass unit, carbon-12 isotope was chosen as the standard reference for measuring atomic masses. One atomic mass unit is a mass unit equal to exactly 1/12 the mass of one atom of carbon-12. The relative atomic masses of all elements have been found with respect to an atom of carbon-12. The relative atomic mass of the atom of an element is defined as the average mass of the atom as compared to 1/12th the mass of one carbon-12 atom. Students, let us learn about molecule and its structure. Molecules are groups of 2 or more atoms that are held together by chemical bonds. They are the basic building blocks of many things around us, like water, air, and even our bodies. Molecules are formed when atoms join together to share their electrons. When this happens, they become more stable and can create different types of substances with different properties. Example, 2 hydrogen atoms and 1 oxygen atom can join together to form a molecule of water, which is essential for life. 1 oxygen atom and another oxygen atom combines to form 1 oxygen molecule. 1 oxygen atom and 2 carbon atoms combine to form 1 carbon dioxide molecule. Now, what is atomicity? The number of atoms in a molecule defines its atomicity. For example, a molecule of oxygen consists of 2 atoms of oxygen, and hence it is known as a diatomic molecule. If 3 atoms of oxygen unite into a molecule, instead of the usual 2, we get ozone, which is a triatomic molecule. Molecules may be monoatomic, diatomic, or polyatomic. Now, what are ions? The charged particles or atoms are called ions. They are formed by attaining a positive charge or negative charge on them. A positively charged ion is called a cation, for example, sodium ion. A negatively charged ion is called an ion, for example, chloride ion. Valency. The combining capacity of an element is known as its valency. Valency is used to find out how an atom of an element will combine with the atom of another element to form a chemical compound. If an atom consists of 1, 2, or 3 electrons in its valence shell, then its valency is 1, 2, or 3 respectively. If an atom consists of 5, 6, or 7 electrons in the outermost shell, then it will gain 3, 2, or 1 electron respectively, and its valency will be 3, 2, or 1 respectively. If an atom has 4 electrons in the outermost shell, then it will share these electrons and hence its valency will be 4. If an atom has 8 electrons in the outermost shell, then its valency is 0. Writing chemical formulas. The chemical formula of a compound is a symbolic representation of its composition. To write the chemical formula of a compound, we need to learn the symbols and combining capacity of the elements. The rules that you have to follow while writing a chemical formula are: the valencies or charges on the ion must balance. When a compound consists of a metal and a non-metal, the name or symbol of the metal is written first. What is the number of the ion? For example, symbol of calcium oxide, symbol of sodium chloride. If a compound consists of polyatomic ions, the number of ions present in the compound is indicated by enclosing the formula of the ion in parentheses and writing the number of ions outside the parentheses. For example, symbol of magnesium hydroxide Here are some more examples of formulas of some simple compounds. Formula of sodium chloride, formula of magnesium chloride, formula of calcium oxide, and formula of aluminium oxide. Now, what is molecular mass and formula unit mass? Molecular mass is the sum of the atomic masses of all the atoms in a molecule of the substance. It is expressed in the atomic mass unit. Formula unit mass. It is the sum of the atomic masses of all atoms in a formula unit of a compound. The constituent particles are ions. So students, molecules, the groups of atoms held together by chemical bonds, are the building blocks of the world around us. They form the air we breathe, the water we drink, and even ourselves.
We hope that you have understood the topic. You can now study chapter notes, watch video lectures, and solve MCQ tests of this chapter on EduRev to ensure you score well in your school exams. And that's not all. You also get amazing courses for maths, science, English, Hindi, and much more for class 9. Thank you.